Question number 6. If angle A and angle B are acute angles, acute means less than 90, such that cos A is equals to cos B, then show that angle A is equals to angle B. So here cos A is equals to cos B is given. We need to find angle A is equals to angle B. So here cos is given in terms of angle A and B. So draw the right angle triangle, but A or B cannot be our right angle. That means A or B is not equals to 90. Okay, so I put A and B here, and already it is given that angle A and B are acute angle. So our third angle C will be 90 for right angle triangle, right? Then what is given? It is cos A is equals to cos B. Now formula of cos A. Now A is our reference angle, so adjacent, that means AC upon hypotenuse AB. So AC by AB. Then for cos B, now B is a reference angle, adjacent BC and hypotenuse AB. So cos A is equals to AC by AB and cos B is equals to BC by AB. Now cos A is equals to cos B given, then put the value of cos A and cos B. Okay, so denominator is same AB, so AB cut from both the side. So our AC is equals to BC. Now, so AC is equals to BC. Now if two sides of a triangle are same, then angle opposite to same sides are equal. So opposite angle of AC, it's a B. So angle B, and opposite angle of BC, it's a angle A. So angle B is equals to angle A, right? So we get angle B is equals to angle A, hence proved. And reason is, that is already written here, angle opposite to equal sides are equal. Okay. Question number 7. If cot theta is equals to 7 by 8, then evaluate. Two question is there. One is 1 in bracket 1 plus sine theta into in bracket 1 minus sine theta upon in bracket 1 plus cos theta into in bracket 1 minus cos theta. And second thing is cot square theta. Second thing is very easy. If cot theta is equals to 7 by 8, then cot square theta. So cot square theta is equals to square of 7 by 8. So it's a 49. 7 square 49 and 8 square 64. So it's easy. 49 upon 64. But we need to find first question, and for that we have two methods. First method is a triangle method, so make one triangle. You know that cot theta is equals to 7 upon 8. First of all, give any name to this triangle, that is ABC we are given here. Now we give theta to angle A. So 7 by 8 cot theta. Cot theta means adjacent AB. So AB is equal to 7k numerator, and in denominator opposite side it is BC. So BC is equal to 8k, right? Because cot theta is equal to adjacent upon opposite. So 7 is adjacent numerator and denominator 8 is equal to opposite, and we give 7k and 8k to AB and BC. Now find third side by using Pythagoras Theorem. So AC square is equal to BC square plus AB square, and we need to take square root. So AC is equal to under root of BC square plus AB square. Now put the value of BC is 8k and value of AB 7k. So 8k square it's 64k square and 7k square it's 49k square, and addition 113k square. Now square root of 113k square. So square root of k square it's a k, and under root 113 as it is. So under root 113k. Now find sine theta and cos theta, because that two value we required. Okay. So first of all, sine theta. Opposite side it's a 8k and hypotenuse under root 113k. So k cut. So 8 upon under root 113. Then cos theta. adjacent, it is 7k upon hypotenuse under root 113 k cut, so 7 upon under root 113. Now put the value of sine theta and cos theta in the question. Okay, so here in place of sine theta, first of all, here use one formula. It is if you look at the question, then it is the form of x plus y and x minus y. X is equal to 1 and y is equal to sine theta. Right, so x plus y and x minus y. So x plus y and x minus y, answer is first term square, that means x square, minus second term square, that means y square. Now first term x is equal to 1, so 1 square 1, minus second term y, so y square, that means sine square theta. We do not need to write this, we need to directly apply this formula. It is 1 minus sine square theta, but for explanation I written this. So directly write down 1 minus sine square theta, same way in denominator, again 1 plus cos theta, 1 minus cos theta, x plus y, x minus y. So first term it is 1 square 1 and 10 minus sine, and second term square it is cos square theta. Right, so 1 as it is, sine square theta, then sine square theta, so 8 upon under root 113 all square, so 8 square 64 and under root 113 square only 113. Right, so 1 minus 64 upon 113, then in denominator again 1 as it is, cos square theta, cos theta is equal to 7 upon under root 113, then square 7 square 49 and under root 113 square only 113. Now take LCM. So here 113 ones are 113 minus 64, it's a 49 upon 113, divide by, again take LCM, 113 minus 49, it's a 64 by 113. Now your denominator will be cut out, so 49 upon 64, it's your answer. 49 upon 64. Second way, if you do not want to do this, then one easy way we have, formula of 1 minus sine square theta is equal to cos square theta, that we already learned in the video of theory part 2, and denominator 1 minus cos square theta is equal to sine square theta. Right, so you can write like this, cos theta plus sine theta all square, cos theta upon sine theta, it's a cot theta, and square, so cot square theta. Right, so cot square theta, that we already find out, say 49 upon 64. So this is easy way, right, because in this way we do not need to do all this calculation, directly we get our answer. Right, so this way we can also use here. Question number 8. 3 cot A is equals to 4, then check whether 1 minus tan square A upon 1 plus tan square A is equals to cos square A minus sin square or not. We need to check it. Okay, we without using this value we also can prove this. Now take LHS first of all, it is 1 minus tan square A upon 1 plus tan square A. Now we know one identity, 1 plus tan square A is equals to sec square A, our second identity, second otherwise third identity, right? So 1 plus tan square A is equals to sec square A. Now we can give separate denominator to both this term in numerator, that means 1 upon sec square A and tan square A upon sec square A, right? Because these two are same, we can give separate denominator. Okay, then 1 upon sec square a. Inverse of sec, it is cos. So we can write 1 upon sec square a is equals to cos square a. Then tan square a. Tan square a means sine square a upon cos square a. And sec is inverse of cos. So in place of sec square a, we can write 1 upon cos square a. Right? So cos square a is it is. Then in second term, denominator are same, cos square a and cos square a. So we can cut it. So sine square a upon 1, it is sine square a, no need to divide by 1. So it's our RHS. So it is equal, it is true for all the value, right? All the value of tan a, cos a or sine a, it's always true. But here value is given, so we go for this method, that is triangle. Here cot a is equals to 4, 3 cot a is equals to 4. So find out cot a, transfer 3 to the right hand side, 4 by 3. Now keep one thing in your mind, your a is not right angle, so draw triangle and give a. Then I give b and c. Angle b is equals to 90 degree. Then for a, opposite side and adjacent side. So cot, formula of cot a is equals to adjacent side upon opposite side. So this is adjacent side, it is AB 4k and opposite side 3k. Okay, then find out AC by using Pythagoras law. Now you know this, AC is equals to under root of BC square plus AB square. BC is equals to 3k, AB is equals to 4k and square. So 3k square, it's a 9k square and 4k square is 16k square, right? 4k square 16k 4k whole square 16k square and 3k whole square 9k square, because addition is commutative process. So we can change the order, but here no need to change the order, but it is written in this PDF, that's why I tell you. If we do not change the order, then even we get same answer. Okay, so 16k square plus 9k square is equals to 25k square, and square root of 25k square. Three things we want here, tan, cos and sine. Tan a we can directly get if we inverse this 3 by 4, because tan a is the inverse of cot a. Then change the numerator and denominator. So tan a is equals to 3 by 4. Sine a, opposite upon hypotenuse, opposite 3k, hypotenuse 5k, k cut, so 3 by 5. And cos a, adjacent, that means 4k upon hypotenuse 5k, again k cut, 4 by 5. Okay, then put this value in left hand side and right hand side. Okay, now left hand side, 1 minus tan square a, 1 plus tan square a. So 1 as it is and then tan square a. So 3 by 4 square, 9 upon 16. And in denominator again 1 as it is plus as it is and tan square 9 upon 16. Take LCM. So here 16 ones are 16 minus 9. Okay, 16 ones are 16 minus 9 divided by 16, and in denominator take LCM. So 16 ones are 16 plus 9 by 16. This 16 cut out. 16 minus 9 7 and 16 plus 9 25. So left hand side is equals to 7 upon 25. Then right hand side, cos square a minus sine square a. Cos a is equals to 4 by 5, sine a is equals to 3 by 5. So 4 by 5 square, 16 by 25, 3 by 5 square, 9 by 25. Then denominator is same, then no need to take LCM, so directly 16 minus 9, 7 upon 25. So our left hand side and right hand side are equal. So from that we can say that 1 minus tan square a upon 1 plus tan square a is equals to cos square a minus sine square a. You will also learn one thing. If you take a science stream, then in 11th standard you will learn that this is the formula of cos 2 theta, and this is also the formula of cos 2 theta. So both are same. 1 minus tan square 1 plus tan square, it is a formula of cos 2 theta, and cos square minus sin square, it is also the formula of cos 2 theta. Question number 9. In triangle ABC, a right angle at B, if tan A is equals to 1 upon under root 3, find the value of sin A into cos C plus cos A into sin C. This is the formula of sin A minus C. And second thing, cos A into cos C minus sin A into sin C. Okay, sorry, this is the first question is formula of A plus C, and second question is formula of cos A plus C. But this thing you will learn in your standard 11 science. Okay, now we need to find this value. So before that we need to have value sin A, cos A, sin C and cos C. So for that we use our triangle method, and for that tan A is given 1 upon under root 3. So make one triangle, and A cannot be your right angle, and also it is given that right angle at B, so B is your right angle. Okay, then take A as your reference angle, opposite side it's your numerator of tan A, because tan A is equals to opposite upon adjacent. So numerator 1, so 1 is your opposite side, so 1k, and denominator it's adjacent side, it is AB, so AB is equals to under root 3k. Then use the Pythagoras theorem and find out hypotenuse. So AC is equals to under root BC square plus AB square, BC is equals to k, and AB is equals to under root 3k. So k square and under root 3k square, that means only 3k square. Now 3k square plus 1k square, it is 4k square, and square root of 4, it's equals to 2, and square root of k square is k. So you got 2k. Right? Then find sin A, cos A, sin C and cos C. So sin A, opposite upon hypotenuse, so kk cut 1 by 2. Okay, then cos A, adjacent upon hypotenuse, adjacent under root 3k and hypotenuse 2k, kk cut under root 3 by 2. Okay, then sin C and cos C. Now C as reference angle, opposite under root 3k and upon hypotenuse 2k, so it's under root 3 by 2. Okay, then cos C, C is your reference angle, adjacent k and hypotenuse 2k, kk cut, you got 1 by 2. Now put this value in your question, you will get the answer. First question, it is sin A into cos C plus cos A into sin C. Put the value of sin A, cos A, sin C and cos C. Your sin A 1 by 2, cos C 1 by 2 plus cos A under root 3 by 2, sin C under root 3 by 2. So as per the rule of board mass, first of all we need to multiply these two things. Now 1 by 2 multiply 1 by 2, 1 1s are 1, 2 2s are 4, so 1 by 4. Here under root 3 into under root 3 only 3, and denominator 2 2s are 4, so 3 by 4. So 1 by 4 plus 3 by 4. Denominator is same, so add the numerator, 3 plus 1 4, 4 by 4 1. Second question, cos A, cos C minus sin A, sin C. Put the value of cos A and cos C under root 3 by 2 1 by 2, and put the value of sin A, sin C 1 by 2 under root 3 by 2. First of all, do the multiplication process. under root 3 1 is under root 3 and denominator 2 to the 4. So under root 3 by 4. Same thing in second term. Under root 3 1 is under root 3 and denominator 2 to the 4. So under root 3 by 4. And subtraction process is there. Under root 3 by 4 minus under root 3 by 4, 0. Okay. One more way we have. We know that tan A is equals to 1 upon under root 3. Now for which value of angle A you got 1 upon under root 3 as your tan theta? We learn about one table, right? In that we got tan 30 is equals to 1 upon under root 3. For 30 degree value, our answer of tan theta is equals to 1 upon under root 3. That we learn in our theory part. Okay. So we can say that our angle A is equals to 30. So our angle C is equals to 60. So directly we have value in our table. That means sine A, cos C, sine C, cos C, all the sine A. That means sine 30. So directly we can say that it's 1 by 2. And cos 30, it's under root 3 by 2 from that table. Okay, then sine C, that means sine 60. It's under root 3 by 2. And cos C, that means cos 60. It's 1 by 2. So without drawing that this triangle, we can directly find this all four value and we can put this value in our equation. Okay. So we can use this way also. Second thing that I tell to you, this is the formula of sine A plus C. Now A 30 and C 60, because tan 30 is equals to 1 upon under root 3. So A 30 and C 60. So A plus C is equals to 90. That means sine 90. Sine 90 is equals to 1. So we got answer 1. Second question. In that, again, this is the formula of cos A plus C. We learned this in 11 science. Okay, again A plus C, it's a 90. So cos 90 is equals to 0. That's why we got answer 0. So here we have lots of way to solve this question. We can use any way, but right now we cannot use that way, that is a sine A plus C, because it is not in the syllabus of standard 10. Okay, so this way we cannot use right now. Other ways we can use to solve this question. Okay. Question number 10. In triangle PQR, right angle at Q, PR plus Q are 25 cm, PQ 5 cm. Determine the value of sin P, cos P and tan P. For all these three value, we need to have our three sides of right angle triangle. Right? Here it is given that right angle triangle, right angle at Q. So draw one right angle triangle, PR, PQR, and in that Q is 90 degree. Then it's given that PR plus QR, PR plus PR and plus QR is equals to 25 and PQ is equals to 5. So first of all, assume QR is equals to X. Assume QR is equals to X. Now PR plus QR is equals to 25. So PR in place of QR, I write down X. So find out PR. PR is equals to, now transfer this X to the right hand side, 25 minus X. Okay. So PR is equals to 25 minus X, QR is equals to X and PQ is equals to 5. Then use the Pythagoras theorem, you will get the value of QR and PR. So Pythagoras theorem, PR square hypotenuse square is equals to sum of square of other two sides. That means RQ square plus QP square. Now what is the value of RP? RP means PR, 25 minus X So 20 minus 25 minus x all square. Then QR is equals to x, so x square, and QP is equals to 5, so 5 square. Now use the identity a minus b all square. So first term square, 25 square, it's a 6 to 5. Okay, 25x all square, first term square 6 to 5, then minus sign, 2 multiply first into second. So 25 into 2, 50x plus second term square, it is x square. So this is your left hand side, 6 to 5 minus 50x plus x square, and right hand side, x square, it is x square, and 5 square 25, right? Now transfer 50x to the right hand side and x square plus 25 to the left hand side. So 6 to 5 is already present in left hand side, and if you transfer x square and 25 to the left hand side, then it becomes minus, so minus x square minus 25, and here we have plus x square also, and transfer 50x to the right hand side, so it becomes plus 50x. Okay, so I transfer x square plus 25 to the left hand side, 6 to 5 and x square both are as it is. If I transfer x square plus 25 to the left hand side, then it becomes minus, and 50x if I transfer to the right hand side, it becomes positive, right? Then your plus x square minus x square cancel, so left hand side 6 to 5 minus 25, 600, here 50x, so transfer x to the left hand side, it goes in division, so 0 0 cut, 60 by 5, it's a 12, so x is equals to 12. Okay, x is equals to 12, then you can find your QR and PR. X is equals to 12, that means your QR is equals to 12 and PR is equals to 25 minus x, so 25 minus 12, it's a 13, right? Now for sine P, P is our reference angle, opposite side it's a x, x means 12, and hypotenuse PR, we got 13, so sine P is equal to 12 by 13. Then cos P, again P is a reference angle, adjacent side 5 upon hypotenuse 13, and then tan P, again P is my reference angle, opposite side QR, it's a 12, and adjacent side 5, so 12 by 5. So I got this three value, sine P is equals to 12 by 13, cos P is equals to 5 by 13, tan P is equals to 12 by 5. Question number 11. State whether the following are true or false. Justify your answer. And first internal question, it is the value of tan A is always less than 1. Now what is the formula of tan A? Formula of tan A, it's a opposite side upon adjacent side. These two sides are independent from each other. Sometimes your opposite sides can be higher than the adjacent side, sometimes your adjacent side can be higher than the opposite side. So if your numerator is higher than denominator, then your answer will be more than 1. If your denominator is greater number, then your answer is less than 1. And we know that at 1045 answer is 1, at 10:0 answer is 0, and at 10:60 answer is under root 3. Now under root 3, value of under root 3, it is 1.732, it is higher than 1. So our statement is false, because it said that value of 10 is always less than 1. But we know that one thing, 1060 is equals to under root 3 and exact value is 1.732. And if we talk about 10a, so it get any real number as an answer. Okay, so range of tan theta, it's all the real number, all the real number can be the answer of tan theta, because sometimes our numerator is greater, sometimes denominator is greater, sometimes we get answer 1, sometimes we get answer 0, sometimes we get answer infinity 1. Okay, so answer of tan theta is all the real number, so we cannot say that it is always less than 1, so that's why this statement is false. Second, sec A is equals to 12 by 5 for some value of angle A. What is the formula of sec A? Hypotenuse upon adjacent side. So hypotenuse is always big side than adjacent side. So our numerator is always greater than the denominator in the case of sec A. Okay, so here it is true, our numerator is greater than the denominator, so this statement is true. Okay, then third statement, cos A is the abbreviation used for the cosecant of angle A. Abbreviation means a short form. Okay, cos A is the short form of cosine, not cosecant, so that's why this statement is false. For cosecant we use cosec theta, right? So this statement is false. Fourth, cot A is the product of cot and A. No, it's a wrong. It is not multiplication, but it shows angle. Okay, cot is one trigonometric ratio of angle A. It is not the multiplication of cot and A. That's why this statement is false. Then fifth, sine theta is equals to 4 by 3 for some angle theta. Now what is the formula of sine theta? It is opposite side upon hypotenuse. Hypotenuse is big side, so our denominator is greater than the numerator. Okay, our denominator needs to have greater value than numerator, but here it's wrong. Here our numerator is greater than the denominator. That's why this is false. And also if you divide 4 by 3, then you get answer higher than 1. And I also explain one thing, that is sine theta always have answer lies between -1 to 1, because our denominator is greater than the numerator, but here it is wrong, our numerator is big number. Okay, that's why this statement is false. So our exercise 8.1 is complete here. Okay, if you have any doubt, then write down in comment section. Thank you.